This is a toughie. Let P of x equals x squared minus x minus 12 all over the quantity x minus 5 times the quantity x plus 1 squared. Identify vertical asymptotes and use limit notation to describe those vertical asymptotes. So let's factor the top two numbers that add up to invisible -1 and multiply out to -12. X minus 4, x plus 3. Leave the bottom the same, x minus 5, x plus 1. Square it. Now let's take the magic numbers, the numbers that make each factor equal to 0. U would be 4, U would be -3, U would be 5, and U would be -1 with the multiplicity of 2. Now let's take a look at what we have. 4 isn't seen on the bottom anywhere else, you're a 0. -3 isn't seen on the bottom anywhere else, you're a 0. -5, a regular 5 isn't seen on the top, you're a vertical asymptote. And -1 isn't seen on the top, you're a vertical asymptote. So what are my vertical asymptotes? X equals -5, regular 5, regular 5, regular 5, and x equals -1. Use limit notation to describe the behavior of P of x as x approaches each vertical asymptote from the left and right. So I need to draw this out to the best of my ability. What numbers do I have? 4, -5, -3, 5, and -1. So I really need a lot of space over here. That is awful, but that's okay. So I have a 0 at 4, so 1, 2, 3, 4. There's a 0 there. I have a 0 at 1, 2, -3, so there's a 0 there. I have a vertical asymptote at 5. 5 is a VA. -1 is also a VA. And let's see what my end behavior is. I have a x squared in the numerator, and x times xx and x cubed in the denominator. So this has a horizontal asymptote at 0. Okay, so you're my horizontal asymptote. Now this is where it gets a little challenging. This is where it's going to get a little challenging. First things first, when I look at my vertical asymptotes and I notice that I'm at -1, okay, when I'm at -1, it's either going to look like that or look like that if the multiplicity is even. But before I even do that, this is either going to hover along the x-axis on the bottom and then scoop up, or it's going to hover along the axis right here and dip down. So what I really need to do is let's plug in, this is -1, -3, let's plug in -2. Because if I get a positive number, and that's all I care about, positive or negative, if I plug in -2, this is going to help us figure out everything. So I'm going to take my original problem, I'm going to plug in -2 and see if it's positive or negative. So -2 squared minus -2 minus 12 all over -2 minus 5 times the quantity -2 plus 1 squared. That gets me positive 4 plus 2 minus 12 over -7 times -1 squared. So you're going to be 4 plus 2, which is 6, minus 12 is a negative on the top. I got -7 times -1 squared, or -7 times a positive, which is a negative on the bottom. So you're going to be positive. So this guy is going to have a point like up here, which means my picture is going to look like this. All right. Now keep in mind, my vertical asymptote at -1, wherever, since the multiplicity is even, wherever it ends up, it repeats at the same spot. So you're going to kind of hover around here, scoop up, and it's going to reappear at the same exact spot, cross 4, and end up down there. Since my vertical asymptote at 5 has a multiplicity of an odd number, it reappears up here and then levels out at 0. So use limit notation to describe the behavior of p of x as x approaches each vertical asymptote from the left and the right. All right? Well, I have two vertical asymptotes, one here at -1. So let's write out that the limit as x approaches -1 from the left means I'm going to -1 from the left and I'm moving upward. So that is going to be positive infinity. And the limit as x approaches -1 from the right of p of x has me going to -1 from the right. That's also positive infinity. Now my other vertical asymptote is 5. So the limit as x approaches positive 5 from the left has me dipping down to negative infinity. And as I go to 5 from the right, I'm going to positive infinity. Very tricky problem, very complicated. But it's done.